So here we've got a diagram of the process. So we pull the trigger, we're going to get a flow of gas. And at the same time, we're going to also get electricity from our power supply that's going to come, it's going to be transmitted to the end of our gun. And then, also when this is happening at the same time, we're going to get our wire, which has a flux inside of it. And as I've said before, maybe our process has gas or it doesn't, but that's the only addition or subtraction between flux core arc welding self-shielded and flux core arc welding gas shielded. So here's the components. We can either have a gas bottle or no gas bottle. And then we've got a wire feeder, a welding gun, and a power supply. That's what we've got happening here. So the power supply is going to supply electricity. The gas bottle is going to supply us our shielding gas. And the wire feeder is going to get us wire with the flux inside to the weld gun. And where it's going to have an electrical current run through it. That electrical current is going to melt the electrode, the sheath on the outside of our wire, and deposit weld metal. And it's also going to break down the flux, which is going to provide us shielding and a slag and a liquid flux that kind of cleanses our weld puddle while the weld is going on. So a GMAW and a flux core arc welding gun are pretty much the same gun. If you're going to use the self-shielded process, there's a couple of different parts, but for the most part, they're the same gun. For gas metal arc welding and flux core arc welding, we can use the same equipment for the most part. So with flux core, with the self-shielding, what we're talking about is we've got a granular flux on the inside of the wire, and that there can be powdered metal, vapor forming materials, deoxidizers, scavengers, and whatnot that are inside the flux. And it's a special formulation depending on what materials we're welding and blah, 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 blah. And then those are going to break down and give us an arc shield that keeps oxygen and nitrogen out of our weld puddle. And those, like I said, here you're going to see we've got vapor forming materials, we've got deoxidizers. Scavengers go in there and clean up your weld puddle, kind of act like a cleaning agent into your weld puddle that helps the weld puddle get the proper mechanical and physical properties that we're looking for. So with gas shielded flux core arc welding, we've got argon, CO2 or other gases, and the flux which we use to shield our weld puddle. Here's a self-shielded flux core arc welding gun. So with the flux core self-shielded, we use generally a lot bigger wire diameters, which means we're going to use a lot bigger current, which means that our weld puddle is going to kick off a lot more radiation. And by radiation, I mean thermal radiation, ultraviolet rays, heat. And this is going to impact the person welding it. So you can see there, we've got a protective hand shield in place, and we don't usually have these on, regular welding guns, MIG welding guns, gas metal arc welding guns, because we're just not using enough current that it's going to really burn the person that's doing the welding. So the temperature right there where your hand is going to be by that trigger is going to get really hot, and it's going to burn your welding glove. And so anyways, they put that protective hand shield in there to deflect a large quantity of the thermal radiation, the infrared radiation coming off of our metal that we're welding and also off of the arc. Here's a cross section of flux core wires. And there's, not that this really matters to us in our world, but this is from a DOD, Department of Defense book back from '68. But anyways, you can see there's different types of, how they pinch the wire together. Just so there's not one size fits all. And this doesn't generally affect us as far, but it's good information to know, I guess. Slag removal. With flux core arc welding, we have to remove slag. It is very similar in that regard to shielded metal arc welding. So slag removal is one of the detriments or one of the disadvantages of this welding process. So you're going to need chipping hammers and grinders and wire brushes to help clean the weld after you've deposited some weld metal. Take the slag off the top. Advantages: high deposition rates, deeper penetration than shielded metal arc welding. We can get high quality welds with this, X-ray quality welds. The slag covering helps with larger out of position welds. So we can weld out of position with this filler material that we couldn't with gas metal arc welding. And the self-shielded flux core is draft tolerant. We can weld in the wind with this process where we couldn't weld outside with, a certain amount of air movement with the gas metal arc welding process. So some of the limitations: we got to remove the slag. Way more smoke and fumes than gas metal arc welding and submerged arc welding. If you do flux core arc welding in a building, especially the self-shielded flux core, there's going to be a lot of smoke and fumes. So this is the health side. We really got to look at this. Spatter. Flux core arc welding wire is more expensive per pound because it's not just a wire. It's not just coat hanger on a spool. There's a manufacturing process where they have to take the steel ribbon, the metal ribbon, and put the flux in it to manufacture it. And then they got to neck it down and spool it and whatnot. So there's an expense there, an added manufacturing expense that isn't there with gas metal arc welding wire. And the equipment it's the same equipment as gas metal arc welding, but it's going to be a little more expensive than shielded metal arc welding. Questions, comments, thoughts, concerns? You can contact me or the other instructor, Ray, through the Udemy website. You got any questions? We'd be happy to hear from you.